All right, guys, not really sure what happened there. For some reason, the iPad shut off. But let's go ahead and finish this up. All right, so it says that it must be an equilateral triangle. What is special about the four triangles within triangle ABC? So here we have our whole entire triangle, and it wants to know, we've got four separate triangles here. That's all within that same big triangle, and it wants to know what's special about those four triangles. Well, since we know that triangle ABC is an equilateral triangle, and since we know that triangle EFD is an equilateral triangle, all four triangles must be what? They must be equilateral triangles. And if all four triangles must be equilateral triangles, then they must be what? They must be congruent. How many times greater is the area of triangle ABC than the area of triangle CDE? Well, let's look at this. ABC is our big triangle, and I'm looking at CDE, triangle number 3. So how many times bigger is ABC than CDE? Well, how many triangles did we divide it into? We divided the whole entire triangle into 4 triangles, so therefore, the area of triangle ABC is 4 times greater than triangle CDE. All right? Since we know that we divided that big triangle into 4 equal parts, or into 4 equal triangles, then the area must be 4 times greater. Alright, so it's time for just a little bit of discussion. They want us to define the terms angle, interior of an angle, and angle bisector. So let's talk about the definition of an angle. I'm going to give you the technical term when it comes to, or the technical definition when it comes to an angle, and then I want to talk about it just a little bit. So the definition of an angle is the union of 2 non-collinear rays with the same endpoint. Okay? Now let's talk about what that means. Okay, so we learned the definition of collinear. And the definition of collinear means that I can take 3 or more points and I can draw a straight line through all of those points. And I will touch every one of those points. So non-collinear means that I've got points that are going to not be in a straight line. So maybe it looks something like this. Alright? So it is the union. Union means together. So it is putting together of 2 non-collinear rays. Guys, a ray is starts at an endpoint and then continues in one direction forever. So we create a ray looking like this. That means it stops here, but it continues in this direction forever. So if I take and create two rays that are non-collinear and they have the same endpoint, that means this is the endpoint. So now I've got two non-collinear rays with the same endpoint, and that is the definition of an angle. I think most of you, or hopefully all of you, do know what an angle is, what it looks like. Every angle has two angle measurements. All right? Every angle has two measurements. This part right here is what we call the interior. So I can measure the interior of my angle. The interior of an angle, angle BAC, is the set of points of the intersection of the half plane of AC that contains B and the half plane of AB that contains C. The interior is easy to identify because it is always the smaller region of the two regions defined by the angle. All right? The region that is convex. So the smaller part, the inside, if you will, of the angle is the interior of the angle. The second angle measurement that we have is this part. And this is called our exterior. Okay? This is called our exterior. I can measure that outside of that angle. It's going to be the bigger part. The exterior of the angle is going to measure somewhere between 180 and 360. All right, so it's going to be between 180 degrees and 360 degrees. My interior is going to be between 0 and 180 degrees. All right, so that hopefully will help you a little bit more when it comes to measuring angles. All right. The main thing to keep straight is that degree measurements do not automatically correspond to angles. A degree measurement may be referring to an angle, an arc, or a rotation that we're going to talk about later. Just because you see the degree does not mean it is an angle. Right now we are talking about angles, but I want you to make sure you understand that just because I see a degree sign does not mean I'm specifically talking about angles. An angle bisector. All right, let's talk about an angle bisector. If C is in the interior of angle AOB, and the measure of angle AOC is equal to the measure of angle COB. All right, so let's kind of draw this out. To me, I think pictures help. So I have angle AOB. So angle AOB. And it says C is in the interior. So C is somewhere around in here, which means I can actually draw a ray. So if I know that the measure of angle AOC is equal to the measure of COB, if I know that this is equal to that, OB and ray OC is called the bisector of angle AOB. When we say, and we're going to put this here to make sure you understand it. So when we say that the measure of angle AOC is equal to the measure of angle COB, what we mean is that the angle measures are equal. They have to be the same measurement. All right, they have to be the same measurement. Guys, questions? Please make sure you catch up with me at some point, weekly or daily Zoom meetings, Monday and Wednesday. You can schedule a Zoom with me on Tuesday, Thursday, Friday. You can come in person. Just get with me if you have any questions. Once again, please do not turn this packet in until we have completed the lessons. We are not finished with this.